You tap send, and the message vanishes. Not in a magical way, in a kind of way where your words get chopped into thousands of tiny pieces and launched into a worldwide obstacle course. Because send isn't a button, it is a trapdoor. And the moment you press it, your message starts sprinting through cables, routers, radio waves, spam filters, and a dozen invisible checkpoints, some of which can rewrite its fate. So, what actually happens? And why does a message sometimes arrive instantly, but other times it hangs on sending like it is thinking about its life choices? How does your phone know where mom lives on the internet? What exactly is traveling, your full message or something smaller? And here is the creepiest one. What parts of your message can still be seen, even if it is encrypted? Let's follow your message the second you press send. The first thing that happens is surprisingly boring. Your device doesn't send an email or send a direct message. It sends a request. Basically, hey, I have data. Who do I hand it to? Because your phone or laptop doesn't know the whole internet. It knows its nearest exit. That exit might be your Wi-Fi router at home or a cell tower if you are on mobile data. Either way, your device converts your message into a stream of bits, ones, and zeros, then pushes it toward the closest on-ramp. And here is the first twist. Your message does not leave as one neat package. It gets sliced into packets, little digital envelopes. Each packet carries a chunk of your message, plus a label that says where it is going and how to reassemble it later. Think of it like mailing a long letter by tearing it into 50 postcards, numbering them, and dropping them into different mail trucks, all at once, which sounds insane. But it is one of the reasons the internet is so fast. Now your packets hit the first major character in this story, the router. A router is basically a traffic cop with a map, except the map is incomplete and constantly changing. It looks at each packet and asks one question: where should this go next? Not where is the final destination. Just what is the best next hop right now? Routers make these decisions in milliseconds, using routing tables that get updated constantly as cables go down, networks get congested, and paths get rerouted. So here's a weird fact that makes send feel less solid. Two packets from the same message can take completely different routes across the world. One might go Amsterdam to Frankfurt to London. Another might go Amsterdam to Paris to New York to London. And they still arrive and get stitched back together like nothing happened, most of the time. Because the internet has a built-in philosophy. Deliver what you can, fix it later. Okay, but how does your device even know where to send it? You do not type an IP address, you type a name. For example, gmail.com, whatsapp.com, outlook.office.com. That is where the Internet Phone Book shows up, DNS, the domain name system. DNS translates human-friendly names into machine-friendly addresses. Before your message can travel, your device asks a DNS server where that name is right now. Your device might ask, where is gmail.com right now? The DNS server replies with an IP address, like handing you the coordinates of the building you are trying to reach. This lookup often happens so fast you never notice. But if DNS is slow, blocked, or confused, your message cannot even find the starting line. It is like trying to mail a letter without an address, while your pen runs out. Now another twist, this one is about secrecy. A lot of people imagine the internet like a private tunnel. You press send, and your message zooms safely through a protected tube to the recipient. Myth. The internet is closer to a busy city. Your message has to pass through intersections owned by different companies, countries, and networks. So the modern internet relies on encryption to keep your message from being readable along the way. When you see HTTPS in a browser, or when your email provider uses transport layer security, your device and the service are basically doing a rapid secret handshake. Are you who you say you are? Here is a key. Here is a lock. Cool. Now let's speak in code. So even if someone intercepts the packets, they mostly see scrambled noise. But here is the catch. Even when content is encrypted, metadata often is not. That can include things like who you are connecting to, when you sent something, how big it was, and sometimes which network it traveled through. It is the difference between not being able to read the letter, but still seeing the envelope. Now we split into two common worlds, instant messaging and email. They look the same to you, but behind the scenes, they behave very differently. Let us start with messaging apps. When you send a message on a chat app, your phone typically connects to that app's servers and sends a short instruction. Here is the message. Please deliver it. Those servers act like a post office and a temporary storage locker. If your friend is online, the server can deliver it right away. If they are offline, the server holds it until they come back. That is why messages can feel instant, but also pending. Now, a small twist. The delivered checkmark usually does not mean the person saw it. It usually means the server successfully passed the message to the recipient's device, or at least to the recipient's account. Read is a whole other signal. Depending on the app, that signal can be optional, delayed, or faked by notification previews. So your message might be traveling, arriving, and waiting while you stare at two little ticks like they are a medical diagnosis. Email is older, and it is weirder. When you send an email, your device does not typically talk directly to the recipient's inbox. It hands the message to your email provider's outgoing server using a protocol called SMTP, Simple Mail Transfer Protocol. Simple only in the way that a simple airport has 14 security lines. Your provider's server then looks up the recipient's domain, for example, example.com, and asks DNS for a special kind of record. That record tells it which server handles mail for that domain. That answer comes from an MX record. Then your provider's mail server tries to hand the email off to the recipient's mail server. So email is a relay race from your device to your provider, to the recipient's provider, to the recipient's inbox. And in between, filters. So many filters. This is where your email enters the judgment zone. Spam filters do not just scan for obvious scams. They score your email like a suspicious job application. They look at your sender reputation, whether your domain is authenticated, whether the wording resembles known spam patterns, whether there are weird links, whether the attachments look risky, and whether you have been ignored by 1,000 people in the past. Sometimes your email is not blocked. It is quietly redirected into the spam folder, like a bouncer politely guiding you away from the main room. Even a perfectly normal email can be delayed on purpose. Mail servers may throttle suspicious senders, slow down delivery when traffic spikes, or temporarily reject an email and ask the sender to try again later. Which means sometimes your email is bouncing between servers with messages like, "Not now, try again, come back later." That is not a bug. It is how email stays resilient. Okay, so where's the message physically? Sitting in a queue on your device, waiting at your router, flying over radio waves to a cell tower, crawling through fiber under the street, passing through a data center in another country, being stored on a server waiting for the recipient, being retried because one link in the chain blinked out for 2 seconds. And yes, some of it might literally cross an ocean. Because a huge amount of global data moves through submarine fiber optic cables, glass strands the width of a hair running along the ocean floor, blasting light pulses at insane speeds. When you press send, you might be using a cable that is older than your phone and still faster than your brain can fully picture. Now let's talk about the part everyone feels. A lag. Why does send sometimes feel instant and other times like mud? A few reasons. First, signal type. Wi-Fi is usually fast and stable. Cell networks depend on tower load, signal strength, and which generation you are on. Second, congestion. If the network is busy, your packets wait their turn, like cars merging onto a crowded highway. Third, retries. If packets get dropped because of interference, congestion, or a noisy connection, your device resends them. And here is a fun detail. Some protocols are polite perfectionists. They want every packet accounted for. Others are more like, close enough, keep the video playing. That is why a video call can keep going even if it looks like a glitchy painting, while a file upload just stalls. Different priorities, different rules. So, when you press send, is your message truly gone? Not necessarily, because there is another invisible layer: storage. Messages often get stored on your device, on your provider's servers, in backups, in logs, in caches, and sometimes in deleted folders that are not truly deleted yet. Even if an app uses end-to-end encryption, the fact that something happened can still be recorded. That includes timestamps, device activity, and delivery receipts. And if you are sending a work email, your message might be archived by company systems for compliance. So the practical takeaway is not paranoia. It is awareness. Send is not a whisper into the void. It is a copied, routed, logged, delivered, and stored event. Now the final loop we opened. How does the recipient get it so quickly? Push notifications. Your phone keeps a lightweight connection open to notification services, so it can be tapped on the shoulder instantly. When the message arrives at the server pings the notification service, which pings your phone. Your phone lights up. Dopamine. You check. And suddenly you are living inside a system built to move tiny packets of meaning across the planet in under a second, so your brain can feel heard. That is kind of wild. So what can you do with all this? Here are a few practical choices, small human-level moves that match how send actually works. First, assume delays are normal. If a message hangs, it may be retrying, waiting for network, or stuck in a server queue. Not necessarily ignored. Second, treat email subject lines like routing signs. They do not route the email technically, but they route attention. Filters and humans both respond to clarity. Third, be careful with attachments. Big files increase size, scanning time, and delivery friction. If it is huge, a link is often smoother. Fourth, use two-factor authentication. Because the weakest point is not the fiber under the ocean, it is the human at the keyboard. Fifth, remember, metadata exists. If something is truly sensitive, choose tools designed for that level of privacy and do not assume deleted means gone. And finally, respect the CC button because send is a trapdoor and CC turns it into a trapdoor with an audience. So the next time you press send, picture what you are really doing. You are not tossing a message into the air. You are launching a swarm of numbered packets through routers that make snap decisions, through cables that cross oceans, through servers that judge, queue, store, when need or retry. All so your words can land intact in someone else's pocket. A button that looks tiny, but opens the whole world. And that is the secret of send. It does not make your message disappear. It makes it travel.